Now, before we start this question, so I would like to introduce this question to you. So this is about the particle in a box, and that is an infinite dimensional box. But unlike the usual potential, which is 0 from 0 to L, you have the three special cases, as you can see in your figure, where there is some finite potential V naught in different arrangements in all the three cases. So the idea is we have to find the relation between the ground state energy of the particle for three of these potentials, like how they are, what is the inequality that relates them. Now the first concept which comes to our mind is the basically infinite potential. Well, you should be aware of the eigenstates and eigenvalues of that. Now the second thing is the perturbation theory. Now you can always think of adding this sort of V naught at different places in the potential as a perturbation. Okay, so when you have a perturbation, you can always find the correction to the ground state energy. So that is the idea of this question. So before we start, let's write the general eigenstate, the ground state wave function for infinite potential. That is just 2 by L square root sine pi x by L. Now for the case 1, let's consider the case 1 first, where you have the potential like this. And then you have a V naught potential in 1/3 of the size of the well. So this is L by 3, this is L, and here it is infinity, infinity, and here it is V naught. Okay, so what you can say is your perturbation H prime. So H prime is the perturbation, and you can write H prime as V naught 0. V naught is from x0 to L by 3 else. Okay, so that's our perturbation. Now the correction, let's represent the correction which is to the ground state energy. So we would call it this thing, the correction to the first order. So this would be nothing but psi h prime psi, and that is simply the integral of the where the potential is non-zero, it is from L by 3, and the value of the potential, and the sine squared pi x by L dx. So that is 2 V naught by L, 1 minus cos 2 pi x by L by 2 integral from 0 to L by 3. Now let's do the integration, which is x by 2 from 0 to L by 3. So if we just put the limits in this integration, you would get this thing, that is L by 6 minus L by 4 pi into okay, now that value is 2v naught by 6 minus 2 by 4 pi into root 3 by 2 v naught. So which is v naught 1 by 3 minus root 3 by 4 pi. Now if you just solve such thing, then you can easily see this is nothing but you just have to calculate this value. This is around 0.33 and this one is around, if you just approximate it, 1.732 by 4 into 3.14, which is around 2 by 12, which is around 0.166. So this is approximately, if you calculate using the calculator, this is this number, but you can just estimate it is around 0.2. So this is the number. Now you do it for the other potential. Now the second case, so you have the E1, the correction. So your E1 0 is 0.195 V naught. Just keep that number in mind. Second case, the perturbation is like this. You have in the middle the L by 3 portion as V naught. Now it might seem all of it just should be same. It's not that intuitive. Okay. So yeah, your perturbation is now in that case your correction would be, the first order correction would be so this was the first order correction. Two by L integration L by 3 to L by 3 now again it's the same integration, you can just do that very simply. Now in that case you would be getting the terms from the, so this would be the number if you solve the integration like I did for the first part, and if you just calculate this, this would be around 0.6 V naught. So E21 is 0.6 V naught. Now you do it for the third case where it is in the L by 6 on both sides. L by 6, 5L by 6. So it would be, the integration would be, so first the potential would be okay. Now in that case the perturbation turns around to be just two sums, like from this, which is 2 V naught by L again, and the another term which is this. sorry, this is pi x by L. Okay, now in that case, if you solve these two integrations, these would be nothing but, and giving you twice, because it's the sort of the, if you put the limits, it would be nothing but twice of that value, and that is, you just need to do this from L by 6. So the only thing that is gonna change is the limit in the case of the first case, right? So it would be 4 V naught by L naught and L by 24 twice minus 3 root 3 by pi, and that is minus 0.0575 V naught. So now you can clearly see your E, what the correction E2 is much greater than E1. E31. So if you add E naught to all this, this is the ground state energy just without the potential well, and this is the new one now, E2 greater than E1 greater than E3, so which is option A. So yeah, this was just the question about calculating it correctly. Thank you.